Welcome to the Semper AI Digest. I'm Tomas, your AI research lead, always scanning the horizon for what's next.
And I'm Aiva. Together, we keep you sharp, informed, and ahead of the curve.
Let's get into it. Holy moly! Google just dropped something that could completely change how we think about AI understanding the world. We're talking about Gemini Embedding 2, their first truly native multimodal embedding model that can create unified representations across text, audio, video, and images all at once. And wait until you hear what this means for everything from search to content creation.
Plus, we've got some fascinating takes on why our current development tools might be fundamentally broken and what AI-first workflows could look like. I'm Aiva.
And I'm Tomas. Welcome to Semper AI Digest, where we break down the AI news that actually matters.
Let's dive right into this Google announcement because, Tomas, when you first sent me this paper, I'll admit I wasn't immediately blown away by another embedding model, but the more I dug into it...
Right? It's like, oh great, another embedding model. But then you realize what Google actually built here. Think about it this way. Imagine if instead of having separate translators for English, Spanish, French, and Mandarin, you had one person who could think in all four languages simultaneously and create meanings that work across all of them. That's essentially what Gemini Embedding 2 is doing, but for completely different types of content.
That's actually a perfect analogy. So walk me through what makes this different from what we've had before, because I know there have been multimodal models that can handle different input types.
Okay, so the key word here is native. Most multimodal embedding models are basically Frankenstein creations. You take a text encoder, bolt on a vision encoder, maybe add some audio processing, and then try to align them in a shared space. It works, but it's clunky.
Like trying to translate everything into English first before doing anything else with it.
Exactly. But Gemini Embedding 2 was trained from the ground up to understand the inherent relationships between modalities. So when it sees a video of a cat playing piano, it's not processing the visual frame separately from the audio separately from any text descriptions. It's creating one unified representation that captures the essence of cat playing piano in a way that connects naturally to text descriptions, similar videos, related audio clips, whatever.
That's interesting. And this comes straight from the Gemini architecture, right? So it's leveraging all that multimodal training that went into the main Gemini models.
Absolutely. And here's where it gets really exciting. The performance numbers they're showing are pretty substantial. On text retrieval tasks, it's competitive with specialized text-only models. On image text retrieval, it's beating a lot of the current multimodal approaches. But the real magic happens when you start doing cross-modal searches.
Give me an example of what that looks like in practice.
All right, so imagine you're searching for energetic morning routine. With traditional approaches, you might get text articles about morning routines, maybe some images tagged with morning routine keywords. But with GE2's unified representations, you could find an upbeat podcast episode about productivity, a time-lapse video of someone doing yoga at sunrise, a motivational quote overlaid on a sunrise image, and a Spotify playlist with energetic morning songs, all because the model understands the conceptual relationships across these different media types.
Okay, that's genuinely compelling. But I have to ask, how much of this is theoretical potential versus what you can actually do with it right now?
Fair question. Google's paper shows they tested it on standard benchmarks, and the results are strong. They're reporting significant improvements on tasks like video-to-text retrieval and audio-text matching. But you're right that the real test will be when developers start building applications with it.
And speaking of developers, this is presumably going to be available through Google's AI platform APIs?
The paper doesn't specify rollout details, but given that it's coming from Google DeepMind and they've been pretty aggressive about making their embedding models available, I'd expect to see this in the Google AI ecosystem pretty soon. Though, knowing Google...
Right, they might announce it, show incredible demos, and we won't see it for 6 months. But let's assume this does roll out. What are the implications here? Because embeddings are kind of the invisible infrastructure powering a lot of AI applications.
Oh man, this could be huge for RAG systems. Right now, if you want to build a retrieval system that works across multiple media types, you're basically building separate pipelines for each modality and then trying to merge the results. It's complex, it's error-prone, and the results are often inconsistent.
Because the different embedding models might have completely different notions of similarity.
Exactly. But with a native multimodal embedding model, you could build a knowledge base where a user asks, "Show me examples of effective data visualization," and get back infographics, video tutorials, research papers, and maybe even audio discussions about data viz principles, all ranked by actual semantic relevance rather than keyword matching.
That's pretty compelling for enterprise search applications. I'm thinking about companies that have massive content repositories across different formats: documentation, training videos, recorded meetings, slide decks.
Yes, and content creation tools. Imagine if you could describe a concept or mood, and your creative suite could pull relevant video clips, audio tracks, images, and text snippets that all actually work together thematically, not just based on tags.
Although that raises some interesting questions about training data and copyright, doesn't it? If this model has learned unified representations across media types, what happens when those representations include copyrighted content?
That's a really good point. Google's paper doesn't dive deep into the training data specifics, but you're right that multimodal embedding models raise new questions about how copyright applies to learned representations, especially if the model could suggest, say, audio clips that match the vibe of a copyrighted video.
Right, and unlike text-based models where you can sometimes trace outputs back to training inputs, these unified representations might make it much harder to understand what's influencing what. But setting aside the legal complexities for a moment, what do you think this means for the competitive landscape?
I think Google's making a smart play here. OpenAI has been focused on their general-purpose models, Anthropic's been pushing Claude's reasoning capabilities, but embeddings are this crucial piece of infrastructure that everyone needs. If Google can own the best multimodal embedding model, that could drive a lot of adoption of their broader AI platform.
And it plays to Google's strengths, right? They have massive multimodal datasets from YouTube, Google Images, the web crawl. They've been thinking about cross-modal search longer than almost anyone.
Absolutely. And they've got the distribution through Google Cloud. It's like OpenAI might have the flashiest demos, but Google's building the plumbing that everyone's going to need.
Well, we'll definitely be keeping an eye on when this actually becomes available and what developers start building with it. But speaking of development tools, I want to shift gears to something that caught my attention. There's been some really interesting discussion about how our current development workflows might be fundamentally broken for an AI-first world.
Oh, you're talking about the thread from Theo about source control and development primitives. Dude, I was reading through that and just nodding along the entire time.
Right? So for folks who might not be familiar, Theo's basically arguing that our current tools, get, branches, commits, the whole traditional source control model, were designed for a world of human-only development teams. And maybe that's not what we need anymore.
The way he puts it is so good. He's like, why are we forcing commits as the fundamental unit of work? Why can't I check out the same branch in multiple places at once? Why are work trees such an abomination? And his answer is basically because these tools weren't designed for AI agents.
Let's break that down, because I think there's something really important here. What does he mean when he says commits are a bad primitive?
So think about how we work with Git right now. You make changes, you stage them, you write a commit message, you push. The whole workflow is built around these discrete, atomic units of change that you have to consciously create and describe.
Which makes sense when you're a human developer who's thinking carefully about each logical unit of work.
Exactly. But if you're an AI agent that's making hundreds of small changes, iterating rapidly, maybe exploring multiple approaches simultaneously, forcing everything into the commit model is like trying to eat soup with a fork.
And he mentions Jujutsu, JJ, as getting closer to the right approach. Can you explain what's different about that model?
So JJ treats work as continuously staged. Every time you run a command, it automatically takes a snapshot. You're not constantly thinking about what goes into a commit. The system is just tracking your work as you do it, and you can worry about organizing it into meaningful units later.
That's interesting. It's almost like having infinite undo with automatic versioning, rather than having to consciously decide when something is commit-worthy.
Yes, and Theo's argument is that this is much more natural for AI agents. An agent might try 17 different approaches to solving a problem, and with traditional Git, you either end up with 17 messy commits, or you spend a bunch of time cleaning up the history, or you just work in one giant commit that doesn't tell you anything useful.
Right, and with AI agents, you might have multiple agents working on the same code base simultaneously, exploring different paths, and the traditional branch and merge model starts to break down pretty quickly.
Oh, and here's the part that really got me thinking. His point about open source not always meaning 100% of our code is public 100% of the time. Like, how many projects aren't open source just because the developers can't figure out how to hide their environment variables or work-in-progress features?
That's actually a fascinating point, because right now, if you want to open source a project, it's basically all or nothing. You either make the entire repository public or you don't. But what if you could have fine-grained control over what's visible when?
Imagine if you could open source your main code base, but keep certain packages private, or hide pull requests that are still in development, or delay publishing security fixes until after you've patched your production systems.
That could actually lead to a lot more open source development. I think about companies that would love to open source their core tools, but can't because there's always some configuration file or internal API reference that would leak sensitive information.
And think about it from an AI development perspective. If you're building agents that are contributing to open source projects, you might want their exploratory work to be hidden until it's actually ready for human review.
Although I can see how this could also be controversial in the open source community. Part of the philosophy of open source is that transparency and public development leads to better, more secure code.
That's a fair point. There's definitely a tension there between practical development needs and open source principles. But I think Theo's broader point is that our tools should be more flexible, not that we should abandon transparency.
Right. And when you think about AI agents as first-class participants in development workflows, a lot of our current assumptions start to feel arbitrary. Like, why do I need to write a commit message that explains what changed when the system could automatically generate a semantic summary of the changes?
Or why can't I have the same logical branch checked out in multiple directories at once? If I'm running experiments or if I have multiple agents working on the same feature, the current model forces me into all these workarounds.
It's like we're still using tools designed for a world where developers worked in isolation, carefully crafting each change by hand. But now we have AI assistants that can refactor entire code bases in minutes, and our tools just weren't built for that pace of change.
And honestly, even for human developers, some of these ideas are appealing. How much time do we waste managing Git branches and worrying about keeping things in sync? How many good ideas never get explored because setting up a clean experimental branch is just enough friction to kill the momentum?
That's actually a really good point. Sometimes the friction in our tools shapes our thinking in ways we don't even realize. If it's annoying to create experimental branches, you experiment less. If commit messages are tedious, you batch changes in ways that make the history less useful.
Right. And I think that's what's exciting about rethinking these primitives. It's not just about making things work better for AI agents. It's about removing artificial constraints that have been limiting human creativity too.
So, what do you think this looks like in practice? Are we going to see new version control systems designed for AI-first workflows?
I think we're already starting to see experiments in that direction. JJ is one example, but I could imagine more radical departures. Maybe version control that's built around semantic understanding of code changes rather than line-by-line diffs. Maybe systems that automatically organize your work into meaningful units based on what you're actually trying to accomplish.
Or integration with AI coding assistants that can automatically generate contextual documentation and commit messages that actually explain the reasoning behind changes, not just what files were touched.
Ooh, and imagine if your version control system understood the relationships between different parts of your codebase well enough to automatically suggest when experimental changes should be merged, or when they conflict with other work in meaningful ways.
That could actually help with one of the big challenges in collaborative development, understanding the intent behind changes, not just the mechanical differences.
Exactly. And I think this connects back to the Gemini embedding model we were talking about earlier. If you have embedding models that can create unified representations across different types of content, maybe your version control system could track relationships between code changes, documentation updates, test results, and even design discussions.
That's an interesting connection. Like, instead of just tracking that you changed a function, the system could understand that you implemented a feature that was discussed in a particular meeting and documented in a specific design doc.
Yes, and then when someone else is working on related functionality, the system could surface all that context automatically, instead of making them hunt through commit messages and documentation to understand what was already tried.
Although we should probably acknowledge that some of these ideas are pretty speculative. Moving away from established tools like Git is not going to happen overnight, especially in large organizations with existing workflows.
Oh, absolutely. And there are good reasons why Git became so dominant. It's reliable, it's well understood, there's incredible tooling around it. Any replacement would need to be dramatically better, not just marginally better.
Right, and there's the network effects problem. Even if a new version control system is technically superior, good luck convincing every open source project and every development team to migrate.
But I think the AI agent use case might provide enough pressure to drive real innovation here. Because when you start having AI agents as core contributors to your development workflow, the limitations of current tools become really obvious really quickly.
That's a good point. It's like how mobile apps drove new interaction patterns in UI design. The constraints and capabilities of AI agents might force us to rethink development workflows in fundamental ways.
And honestly, even if we don't see wholesale replacement of Git, I think we'll see new tools and interfaces that make AI-assisted development much smoother. Better integration between AI coding assistants and version control, smarter branching and merging workflows, that kind of thing.
Speaking of AI integration, I keep thinking about the security implications of some of these ideas. Like, if your version control system is automatically generating summaries of changes and exposing more semantic information, what happens if that system gets compromised?
That's a really good point. And Theo mentioned security fixes as one area where current open source workflows are problematic. Like, sometimes you need to delay publishing a security fix until after you've patched production systems. But more intelligent development tools could create new attack vectors too.
Right. If your version control system understands the semantic meaning of code changes, an attacker who compromises that system might be able to identify vulnerabilities more easily, or understand the architecture of your system in ways that simple source code access wouldn't reveal.
On the flip side, though, AI-powered development tools could also make code more secure by automatically identifying potential vulnerabilities, suggesting security best practices, that kind of thing. It cuts both ways.
True, and I suppose we're going to have to figure out these trade-offs as the technology evolves. It's not like we can just stick with current tools forever when the pace of development is accelerating so dramatically.
Absolutely. And I think that's what's exciting about this moment in tech. We're not just getting new AI models, we're being forced to rethink fundamental assumptions about how development works, how teams collaborate, even what open source means.
Well, this has been a fascinating deep dive into both multimodal AI and the future of development workflows. Before we wrap up, any final thoughts on where this is all heading?
I think we're in this amazing period where AI capabilities are advancing so quickly that our tools and practices are constantly playing catch-up. Whether it's embedding models that can understand relationships across completely different media types, or version control systems designed for AI agents, we're basically rebuilding the entire software development stack in real time.
And that creates both huge opportunities and huge challenges. The teams and companies that figure out how to adapt their workflows to take advantage of these new capabilities are going to have massive advantages. But it also means a lot of established practices and tools might become obsolete pretty quickly.
Right. And I think for anyone working in tech right now, the key is staying curious and experimental. Don't just wait for the perfect tools to emerge. Start thinking about how current limitations are constraining your work and look for ways to push beyond them.
Absolutely. And keep an eye on these foundational technologies like advanced embedding models, because they often enable applications and workflows that weren't even possible before.
For sure. All right, that's a wrap on today's Semper AI Digest. If you enjoyed this deep dive into the future of AI and development, make sure to subscribe and share this episode with someone who's as excited about this stuff as we are.
We love hearing from listeners, so if you're building something cool with multimodal AI or experimenting with new development workflows, let us know. Until next time, keep pushing the boundaries.
Thanks for listening, and remember, the future is being built right now, one breakthrough at a time.